Hello and welcome. Today we're going to be talking about atomic structure and the periodic table. Now this is going to extend our learning from what we previously did in Unit 1 this year, when we did look at our periodic table, how things are interacting with each other, and we're just going to be further looking into that there. Okay, so what you'll notice, and maybe you've wondered before, why are elements in the periodic table arranged the way they are? Okay. Now the reason why they are arranged the way they are is that they are arranged according to the way that the electrons arrange themselves around the nucleus of the atom. Now if you remember about the nucleus of your atom, you have your neutrons and your protons in the middle, and you have your electrons outside of it. So if we have our periodic table here, okay, try to get it all in there. Okay, everything that is arranged, so 1, 2, 3, 4, 5, and so forth, those numbers tell us how many protons there are in that nucleus. But why is the periodic table arranged the way it is? Okay, now as you'll notice, everything in group 1, if you remember, they all have one valence electron. They all have that one electron on the outer shell. Everything in group 2 have 2 electrons in that outer shell. Okay, you'll notice that we have our transition metals in the middle. Now, if you remember, your transition metals, they don't follow any pattern. They're all rearranged together. But if we go down to number 3 or 13, okay, the root number there is 3. All of these have 3 valence electrons. These have 4, 5, 6, 7, 8. And then once again, you guys should know that if you have 8 or a full valence shell, you have what we call a noble gas because their valence shell is full. Now, the only exception to this rule here is that helium has 2, but once again, it has a full shell. So that's why it's part of that group. Okay, so once again, that's just got a little bit of a reminder of the way we have our periodic table arranged. Okay, now what we're going to be doing is we're going to be extending our learning into something called quantum chemistry. And quantum chemistry is essentially studying how electrons and the arrangement of our elements and how they interact with each other. So we're just going to start briefly talking about it. And once again, if you ever take post-secondary chemistry, you'll see more in depth than what we're going to be starting off today anyways. All right, so if we go back to this lesson here, once again, you can find our lesson, our periodic table, and all these resources on our class website. And if you do ever have any questions, just send me an email. My email is in our class website as well. And once again, I could direct you and show you where everything is. Okay. Now, if you take a look over here at the bottom, you'll notice it may be a little bit hard to see here, but you have these different categories of how we are labeling our periodic table. Okay, so what I'm going to do is I'm actually going to pull this. Once again, you can find this online on our website, but we have this here. Okay, it's just the exact same picture, just blown up a little bit. Okay, now you'll notice that this here is our periodic table. Okay, and it's all arranged the exact same way that we have our periodic table. So I'll try to get both of these in the picture here so we can kind of get a better idea. Okay, might be a little bit hard to see, but either way, you guys understand. We have our first element here, which is hydrogen. Okay, now the first thing I'm going to tell you guys is that the numbers represent your rows, right? So number 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so forth. Okay, the numbers at the top here is the first elements going down. So that's your first group, group 2, second group going down, group 3, the third one's going down, 4, 5, 6, 7, 8, 9, 10, 11, 12. And once again, that's why it says 3, 4 all the way to 12. Okay, and then we bounce back up to 13 here. And that's why it has 13, 14, 15, 16, 17, 18, 18, also known as our noble gases right there. So it's our periodic table essentially, just ordered in a different way. And once again, I just want you guys to see this first before I start explaining what everything is. Okay, so you notice here that we have our 1, okay, 1s, which is 1 and 1. So this is hydrogen and helium, hydrogen, helium. And then we jump down to 2. And as you'll notice, there's 2 elements here, 2 elements there. Okay, there's nothing over here. We jump across where it says 2p. Okay, and that's these here. Okay, and then if we jump down to the third row, okay, third row, and once again, there's a gap here. So that's why there's nothing over here. And then we go to 3p, which is over here. And then we go to 4s, which is over here. And once again, 4s means it's in the fourth row. Okay, now, this is kind of where things get a little bit complicated, or not really complicated, just something you need to kind of remember. And once again, this sheet here, this white sheet over here, I'll give that to you, especially for what we're doing for the next couple days or in this unit anyways, until you get a little bit more familiar with it. Okay, but once again, you'll notice here it goes from 4s and it goes to 3d. And you might be wondering, why is this here a 3 if it's in the fourth row? Okay, now the reason why they do that has to do with the energy. Okay, and what I mean by that, this 4s has a little bit higher energy than this 3d. Okay, so once again, we'll talk about it. Sorry, the D's have more energy than the S's, but we do that because there is no top rows here. So we bring everything down, shifted 1 row down. So we have 4s, and then we go to 3d, back to 4p, 5s, 4d, and as once again, you'll notice that it's 1 number down. And once again, it has to do with the fact that we had no 3d over here. So everything got shifted down. Now, once again, you'll see that also over here. See how we have 4f? Okay, 4f and 5f. Those correspond to these rows right here, 4f and 5f. Okay. So, let's move on a little bit forward here. Okay, now you'll be wondering what these letters stand for. Essentially, they're just represent our energy. Okay, S's, and sorry, this is what I was talking about before when I was talking about your energies with the 4s and the 3D. Your S's have the least amount of energy. Then you have your P's, which are next. So those are your next energy levels. So just so you guys are all aware, maybe I'll write this down for us. Okay, S, okay, the least energy, or least amount of energy. P's are next. Let's put next. Okay, then we have our D's, which is once again next in line, and then we have our F's, which are the highest energy. Okay, so when they're rearranging this periodic table, once again, you'll have your pictures here. Here, your all your S's, sorry, all your P's. Okay, this one here, helium, is also known as an S. You have all your D's, and then you have your F's. Okay, and the reason why they do that, or they configure the periodic table like this, is that they're going in increasing energy. So once again, your S's are your smallest, and then you got your P's, because that's the next one that comes in line. So you have 1s, 1s, 2s, P's, those are next. So your P's are the second energy. Then you have S, P, S, D. So D's have more energy. And if you keep going down your periodic table, you'll get to 4F, which has the highest, or F's anyways, have the highest energy compared to the rest. Okay. Now, before we get into some questions, and you'll start to understand what we're doing here, this is definitely brand new to you, so it might be a little bit complicated. But once again, if you follow along, we're going to try some questions along the way, and I promise you it will make sense. Okay. Now, before we move on, a couple things that we need to know. Okay. All your S's, they have 2 electrons. Okay. P's have 6 electrons. D's have 10 electrons. And F's have 14 electrons. Okay. Now, so as we move on, we're going to get a couple other things in here. Okay. Another thing that we're going to look at. Okay. Each electron is shown as a half arrow. Okay, now those arrows, the proper terminology or proper notation for it, that's one and that's a second. So those are two electrons, and you'll notice that they're in opposite, we say opposite spins, and we'll see that in the next lesson. But once again, I'm just trying to introduce a couple things now so that this way when we do see it a little bit later, we'll all have a good idea of what's going on here. Okay? All right. So let's flip to the next page. Okay, and once again, we're going to get into some examples and we're going to try it out. Okay. So what we're going to do, we're going to be drawing some energy level diagrams. So we're going to do some diagrams first and then we'll get into the notations. Okay, so how we do this is we begin at the lowest energy state and we build from the bottom up. Okay, we're going to be looking at ions. So obviously anions are your negatively charged. So once again, if you had like oxygen 2 negative, that's an anion because you're adding electrons. If you had something that's positive like lithium 1 plus, right, 1 plus means we lost an electron. Okay, now there's a couple rules that we need to know before we move on. Okay, so I'm going to write these out, and once again, I hope that you write them out along with me. Okay, the first rule, or first principle, is called Aufbau's. A-U-F-B-A-U, Aufbau's principle. Actually, you know what I'm going to do? It might be a little bit easier to do it this way. Okay, I have them actually right here, so I'm just going to slip in. I'm going to cover that. Please don't look at it. That's going to be our example. Okay, but anyways, our first one here is called Aufbau's principle. So I'll read it. Hopefully you can see it. I am using an iPad to record it, so it's not the best quality. But once again, you could always pause it and rewind or whatever you need to do to go back and get it. So the first principle that we need is called Aufbau's principle. Okay, so what this principle states is that electrons must always fill the lowest energy possible first before filling the higher energy orbitals. Okay, so an orbital is what we call just our S's or D's or P's or F's. So we always need to start at the lowest ones first, right? So we have hydrogen is the lowest. So we start here. Then we go next. So you're essentially just going order. So you have hydrogen, helium, lithium, and it keeps moving in order from the lowest levels to the highest levels. Okay, so that's Aufbau's principle. He's just saying you have to start from the bottom and you got to work your way down into higher energy. And you guys remember, S's are the smallest, P's are next, D's F. So we start small and we go bigger. Our next one, we'll go Hund's rule, that's fine. Hund's rule, every orbital needs to be half full before pairing. Now, where you would have seen this, okay, if you remember back when we did Bohr-Rutherford diagrams or even Lewis dot diagrams, let's say, for example, we wanted to do oxygen. Okay, oxygen, if we do a Lewis structure, you have O, and then we put the electrons around. So oxygen has 6 valence electrons. So as you recall, we always start 1, 2, 3, 4. So we go around first before we start doubling up. Oxygen has 1, 2. If we did, for example, fluorine. Fluorine has 7. So it goes 1, 2, 3, 4, and then we start doubling up. So, oh, sorry, that's not O. That should be an F in here. So I'll do it again. F, 1, 2, 3, 4. So we fill it first, and then we go 5, 6, 7. So This essentially is Hund's rule. We just never put a name to this, but Hund's rule says that every orbital, okay, an orbital is where there's two electrons together. Okay, that's one orbital, this is a second, that's one, that's one. Okay, there's just spaces where electrons are going to go together. What it's saying is that they need to be half full first. So that's why we go around once before we start pairing them up. Now, number 2, or this Pauli exclusion principle, okay, this is what we'll see mostly for tomorrow, okay? But what it's saying is this, that no two electrons can have the same set of 4 quantum numbers. We are going to look at quantum numbers in our next lesson or tomorrow. Okay. Now, however, each orbital must have 2 electrons with opposite spin. And once again, this here will come tomorrow or in our next lesson. But essentially, what I was showing you guys before with those spins, okay, that's how we draw a spin here, just like that. What that is essentially saying is that, see how there's 2 electrons in each orbital? There's 2 here, 2 there, 2 there. Okay, this one only has 1, but because these spaces where electrons are, that's what we call an orbital, what we say is that both of these electrons are moving in a different spin. Okay, one's moving one way, one's moving the other. Okay, so what we would say is that this one electron might have a spin going up and this one might go down. This one here, there's one that's up and there's one that's down. There's one that's up, there's one that's down. What about the one that's by itself? That one doesn't matter if you put it up or down. But if we ever added a second one, okay, so let's say this one here had a down spin, okay, we would say the other one has an up spin. Okay, they have to be opposite from each other. Now, how do you know which one's up or down? You don't. Okay, up and down are just ideas saying that they just need to be different from each other. We don't actually know which electron's moving up, which one's moving down. Okay, we actually don't even know where electrons are half the time because electrons are always just moving around. Okay, so what we're trying to differentiate when we put the spins is we're just saying that each electron is different from each other. So it doesn't matter which one's up or down. Essentially what these spins are telling us is that just this electron and this electron, even though they're in the same orbital, they're different from each other. And that's all that's saying. All right, a lot of definitions. Okay, let's jump on down to some examples here. Okay, and we can finally start seeing what this would be like if I ever gave you a question on it. Okay, so the first one, let's draw. Okay, it says draw the energy diagram for carbon. Okay, now what we're going to be doing, okay, and it's not very difficult, it's just new, so there's a lot of explanations or explaining I need to do. This is an energy level diagram. Okay, and typically you'll notice that here is your 1s, and as you move up, we're hitting up higher orbitals. So 1s, 2s, 3s, 4s, 5s, 6s, 7s, and then you have your p's and your d's and your f's. Once again, these are the lowest energies, these are next, then d's, then f's. Okay, now what we're going to do is we're going to go to our periodic table. And once again, you guys remember that here's your 1s, 1s, 2s, 2p's, 3s, 3p's, 4s, 4d. This one drops down a level. And once again, you can see that from our just sheet like here, right? That's the one that you guys have on our class website. So what we're going to do is we're going to draw an energy diagram for carbon. So the first thing we need to do is we need to find carbon on our periodic table. So it's right here. Okay, it's number 6, nice and easy to start off with. So what we're going to do is we're essentially going to draw this here. Okay, this here. This is what we're going to draw. Okay, so what we're going to do is we're going to start from the bottom and we're going to work our way up to the top. Okay, and what this is telling us is the energy. Okay, the lowest energy to the highest energy. Okay, and hopefully you guys can see that there. Okay, so for our drawing of carbon, what we're going to do is we're going to go in order. Okay, so to get to carbon, which levels do we need to pass? So we need to go through 1s. So 1s is 1 and 2. This is 1s. So what we're going to do is we're going to draw, and once again, 1s. If you look at your paper, 1 and 1, these are 1s's. So to get to carbon, carbon's over here. Okay, so we need to pass 1s, we need to pass 2s, and carbon is in this 2p section, which is over here. It's the second one in that 2p section. So what we need to do is we need to go in order. So the first energy level that we're going to pass are the 1s's. So we're going to put, this stands for your orbital, and we're going to put 1s. Okay. So in your 1s, to get to carbon, we need to pass hydrogen and we need to pass helium. So we're going to put one arrow up to represent hydrogen. This represents helium. Okay. Now, once again, we're just working our way to carbon. So we need 1, 2, 1s, 1s, 2 electrons, 1 for hydrogen, 1 for helium. So we have 1 and 2. Next, we're going to the 2s's. So we have lithium, beryllium. So 1s is the lowest, 2s is the next one. So we're going to go from 1s to 2s. So what we're going to do is we're going to draw another orbital, and we're going to put 2s. Now, what elements are in that 2s section? Lithium and beryllium. And we need to pass these two to get to carbon. So we need 1 and 2. Okay, so essentially we have hydrogen, helium, lithium, beryllium, but we need to get to carbon. Okay, so carbon is here. So we have our 2p. Now you'll notice that we typically draw it like this, where we go from 1s's, and the 2p's are a slightly higher energy. So 1s is small, 2s is next. 2p has a little bit higher energy than the 2s, so we typically draw it like this. 2p, and then we have 1, 2, 3. Now, does anyone here know why we have 3 of them there? Okay, now, if you go back here, how many elements do we have in the 2p? We have 1, 2, 3, 4, 5, 6. Each of these stand for 1 electron. So 1, 2, 3, and then we need 3 opposite spins, 1, 2, 3. Just like we did here, we had, for hydrogen and helium, we had 1 arrow going up, 1 arrow going down. So 2 of them covered 1 orbital. 1 orbital is that line that we put there. 2s, 2 electrons, 2 elements, 1 electron each. So that's 2 electrons in total. That's what we have there. So now for 2p, we're only going to carbon. So we only need 1 electron, 2 electrons. So we're going to put 1 electron and 1 electron like that. And once again, you know you did this right because carbon has 6 electrons in total. Right? Once again, it has 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6. So long story short, all you're going to do is you're just going to figure out what number your element is, and that's how many arrows you should have. So let's do another one, and then I'll give you guys a chance to try it. Let's try, we won't go too hard, not yet anyways. We'll try a couple other harder ones. Let's try magnesium. So I'll do right here, Mg, magnesium. Okay, now what I would recommend, I would pause the video right now, and I would try it by yourself and see if you can get it, and then resume it and then listen to my explanation. Okay, so if you want to do that, I highly recommend it. So hopefully you did pause it. If you didn't, we're going to try it together. So the first thing you need to figure out is, where is magnesium? Okay, magnesium's over here. So you need to pass 1s, 2s, 2p, and then we're in the 3s section. So the first thing I'm going to do, I'm going to draw them all out. So I have 1s, okay, 2s, And once again, if you're not too sure how to draw it, use this sheet right here. Look, 1s, 2s, 2p, 3s. So I'm essentially just drawing these three. And as you can see, it can get much higher than that. Okay, so we're going to draw 1s that has 1, 2s, 2p, 3s. And as you'll note, even though that p's have more energy than s's, because that number is higher, that kind of trumps it. If you know the game euchre, the higher the number, the more that energy is. Okay, so we have 1s, 2s. We have 2p that has 3, and then we have our 3s at the top. So for magnesium, how many electrons do you have? You have all the way to 12. So we should have 12 arrows when we're done. Okay, so the first two, for 1s, we have hydrogen, helium. Okay, right? Once again, hydrogen, helium. 2s, we have lithium, beryllium. So I'm going to put lithium one way, beryllium the other. It doesn't matter which way you're putting it. If you want to put the down one first and the up one second, that's fine. They just need to have opposite spins. Now, for our 2p, we have a full 6. So we have 3 arrows going one way and we have 3 arrows going the other. And once again, you need to remember, okay, Hund's rule. Every orbital needs to be half full before we pair. So to do the 2p, we go 1, 2, 3, all one way. And now that they're all half full, we can start doing the next one. So 1, 2, 3. And that gives us a noble gas. That right here gives us neon if we left it here. Right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which element has 10? Neon. So that's where we are right now. 1, 2, all the way to 10. Now we need 11 and 12, which is sodium and magnesium. So those both go in the 3s. So now we've drawn the energy level or energy diagram for magnesium. So it's essentially just counting how many electrons you have. Okay, so let's try another example. Maybe we'll go a little bit further this time so you guys can get it. Let's try, and I'll flip the back side here. Okay, let's try for, we won't go too far deep in this. But let's try bromine. Okay, so once again, let's go ahead. I recommend you pausing the video, see if you can draw it, and let's see how you guys are doing. Okay, go ahead, take a second, and resume the video whenever you're ready. Okay, hopefully you paused it. Now, once again, the first step for me, when I'm looking at it, I'm going to figure out where is bromine on my periodic table. Bromine is over here. It's in the first row, second, third. It's in the fourth row down. So going over here, bromine, if we're looking at here, is in the fourth row going across. It's in that P section. So bromine's here. So in order for me to do the 4P, I need 1s's, 2s's, 2p's, 3s, 3p's, 4s, 4d's, 4p's. You just essentially just go in order. Okay, so we're going to have a lot of arrows because once again, how many arrows should we have? We should have 35. Okay, that number tells us how many protons. It also tells us how many electrons on a neutral element. So for bromine, what I'm going to do is I'm going to start off by drawing my arrow. Okay, and once again, this is new to me. So let's say I'm not sure. Okay, so we figured out we need to go to 4p. So I need to draw everything up to 4p because these are all the energy levels or all the orbitals I'm going to hit. Now, if you don't do it in the exact same, so as you'll see here, 3D is slightly higher than 4s, that's fine. Okay, personally, I don't even do that. What I would do is this. I would go in order. So I have 1s. 2s. I know p's are bigger than s's, so I have 2p's. Okay, and once again, all you really need to do is just go in order. 1s comes first, so that's my first one. 2s's come second, 2p's come third, 3s's come next. Okay, what's after 3s? 3p's. 1, 2, 3, 3p. Okay, now this is where typically we like to just go in order. Okay, so we're hitting 3p, then we're going to 4s. Okay. Next, we're going to 3D. So what we're going to do is we're going to put 3D. Okay. And then lastly, we have 4P. Actually, sorry, for this one here, what I'm going to do is I'm going to keep the 3's on the same level, essentially. So we have 3D, 1, 2, 3, 4, 5, and then we can have our 4P here. Okay, once again, D's have 5, P's have 3, and so forth. Okay, so to do our bromine, sorry about that there. Just try to make everything there. So next, let's just go in order. Okay, so let's go to bromine. Okay, so first we have our 1s. So 1s, 1s. So hydrogen, helium. Next, 2s, lithium, beryllium. 1 up, 1 down. 2 P's. 1, 2, 3, 1, 2, 3. That's full. So I'm going to go 1 all the way across, and then the next one's all the way across. 3s, sodium, magnesium. That was our last example when we looked at magnesium. We only went up to 3s. Next, we have the 3 P's. Once again, a full P section. So we're going to go 1, 2, 3, 1, 2, 3. Okay. Next, we have our 4s. 1, 2. Okay. And once again, you'll notice that I put the 3's kind of all in the similar category. That's what I was showing you before. If you put the 3D's higher than the 4s, I'm not going to mark it wrong. Okay. I would mark this wrong if you put 2 arrows in the same direction. So if you put 2 arrows like that, that would be wrong. I won't be picky, not this year anyways. When we do this in grade 12 or post-secondary, then it would get a little bit more pickier. But right now, as long as you're figuring this all out, that's what's most important. So we have 4s, which is calcium or potassium calcium. And then we have the 3Ds. And once again, you'll notice that there's 5 here because there's 10 elements. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 are up, 5 are down. So we have 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And then we have our P's. So now we need to go to bromine. So bromine in the P section here for 4P, 1, 2, 3. So those are 3, and then 2 down. So we're going to go 1, 2, 3, 1, 2, 3, and then 2 down, 1 and 2. And this here is what bromine would look like. Okay, so hopefully you guys could see that. Sorry, my sheet I just noticed was a little bit off. Okay. That's the fun part with making video lessons. Sometimes you can't see it. But anyways, here's your bromine. And once again, you have 1, 2, 3. So that's why we had 3 going up. And then we had 2 going down because we had 1, 2, 3 going up and then 2 going down, Se and Br. Okay. So hopefully that makes sense, drawing that. Okay. There's a couple other examples. On the next page, you have, where's my page? Sorry. So there's a couple other examples you could try. You could try magnesium. You can try copper. Okay. For us here, what we are going to do instead is we're going to jump down and we're going to try some ions. Okay. We actually already did magnesium. Sorry. Copper, I just switched out for bromine. Okay. So let's go ahead and let's try this one here. So we're going to try some ions. Okay. So the first one we're going to try is the nitride ion. So nitride is nitrogen. What charge does nitrogen make? Nitrogen, once again, if we go on our periodic table, has 1, 2, 3, 4, 5 electrons in its valence shell. It's going to pick up 3 of them. So we say nitrogen is a 3 negative ion. So this is what we call our anion because it's lost. So what's going to happen is we're going to draw this out. And what we're going to essentially do, 3 negative means that we add 3 electrons. So nitrogen is in our 1s, 2s, 2p orbital. So we're going to go 1s, 2s, and then we have our 2p p orbital. So nitrogen is number 7 normally. So I'm going to go 1, 2, 3, 4, and once again, because of Hund's rule, we need to go 1, 2, 3. This here is nitrogen. However, we are looking for the ion. So because we have the ion, we need to add 3 electrons. And where do you think those 3 electrons are going to go? Well, you guessed it. 1, 2, and 3. And this here, once again, you don't have to put in a different color. I'm just doing it for visual purposes, would be the nitrogen 3 negative anion. Okay. What about the sodium ion? So once again, I recommend pausing this video and see if you can come up with the sodium ion. Okay, so take a second, resume the video when you're ready, and we will go through it. Okay, so sodium, once again, if we're looking over here on a periodic table, okay, sodium is over here. Okay, so that is in your 3s section, 1s, 2s, 3s. Okay, so what we're going to do is we're going to go all the way up there, 1s, 2s, we have our 2p, right, you guys can all see that, and then we have our 3s. So, sodium ion, sodium's Na, it's going to be a 1 plus. It loses 1 electron. Once again, it's going to go from here, and it's going to lose 1 electron and become very similar to neon. So essentially what we're going to do is we're just going to draw neon because that is what it is isoelectronic with. And once again, if you remember our unit 1, that's exactly what we talked about. So what we're going to do is we're going to go 1, 2, because 1s's are full, 2s's are full, and then the nitrogen or sodium ion, sorry, is going to have 1, 2, 3, 1, 2, 3. This here is what the sodium ion looks like. Okay. Once again, we're going to keep the 3s there because that's originally where that 1 electron was. But because sodium lost an electron, it lost it there. So this orbital is still here, it's just empty. Okay, so this is our nitride ion and our sodium ion. And once again, very similar to what we've seen all year. Okay, so hopefully this is making sense to you now. Now, just a little bit of a recap of what we looked at earlier this year, something called isoelectronic, and you would have heard me say it on the last slide. Okay, iso means the same. So for example, right, if you had the sodium ion, which is the 1 plus, what noble gas does it look like? So sodium is over here. Okay, it has 1 extra electron. It loses that 1 electron, and when it loses the 1 electron, it's going to have the same amount of electrons as neon here. So we say it's isoelectronic with neon. We also looked at our other example of nitrogen. Nitrogen picked up 3 electrons. So it picked up 1 electron to look like oxygen. It picked up a second one to look like fluorine. But then it picked up a third one to look like neon here. So nitrogen is also isoelectronic with neon. What about bromine here? Bromine is going to pick up 1 electron to become full, and it's going to look like krypton. So we say it's isoelectronic with krypton. Okay, what about phosphorus? Phosphorus is going to pick up 1, 2, 3. So it's going to be isoelectronic with argon. Okay, on this side, let's say calcium. Calcium is going to lose 2 electrons because it's a metal. It's going to lose 1, and then it's going to lose 2. So it's going to look like, or it's going to be isoelectronic with argon. Okay, we talked about this in Unit 1 this year. So that should be a little bit of a reminder, of a refresher of what isoelectronic is. And that's what this here is saying. And this actually is the exact same picture that we have in our lesson. Okay. So our last step in this lesson anyways, is that we're also going to be coming up with what we call the electron configuration. Okay, So once again, it's not too difficult, but we're going to go through some examples and we're going to look at them here. Okay. Now, as you guys are aware, if I had to ask you to do these diagrams every single time, it would get extremely tedious, and some of them could be very long. You might be there drawing 114 electrons, right? I don't want you guys to do that. Excuse me, sorry. And I don't want you guys to be drawing 114 electrons, so we can do this in another way, which is called coming up with the electron configuration. Okay, the first one was the electron diagrams or energy diagrams or energy level diagrams. These are what we call the electron configurations. So let's go through some examples. And once again, I guarantee it's going to be nice and easy for you. Okay, so for the first one, let's write the electron configuration for oxygen. So what we're going to do, once again, we're just going to go in order. Okay, and that's the nice part about this. Okay, so to get to oxygen, we have to go through the 1s's, the 2s's, and the 2p's. So what we're going to do is, instead of drawing them with arrows, we're going to write them out with letters and numbers. So the first thing that we need to go through, once again, we always start from the bottom and work our way up. That is our off-bow principle. Okay, we're going to start off at the 1s section. Okay, so once again, to get to oxygen, over here, we need to go through the 1s. Now, how many electrons are in the s's, or the 1s's? 2 of them. So what we're going to do is we're going to put 1s and a 2. Okay, and what this 2 represents is how many electrons we're going through. Okay, so in the first S, the first level energy, which is the S, we have 2 electrons. Next, from 1s, where do we go next? 1s, then we're going to 2s. How many electrons are in our 2s, or in the s's? 2 electrons. So we're going to put another 2. And then lastly, we're going to go to our oxygen, which is in the 2p section. So we're going to write 2p. Now, the question is, how far in the 2p section did we go? Well, we went 1, 2, 3, 4. So we're going to put a 4. And I'll give you guys a hint. If you add up these numbers at the top, they should add up to the atomic number of whatever you're looking for. So for oxygen, it's atomic number 8. So 2 plus 4 is 8. Now, if you remember from our first slide, I told you this here. S's have 2 electrons, P's are going to have 6, D's 10, F's 14. So that's why on top of the 2, on top of the S's, we have 2. On top of the P's, we can have up to 6, because we can have 6 elements there. 1, 2, 3, 4, 5, 6. These are all the P's here. What about the F's, or sorry, the D's? The D's could have up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which we saw in some previous examples. And then your F's, you have 14. 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14. So that's where these numbers came from originally. So let's try another one. Let's try argon. Okay, we'll do this one together, and then I'll get you to try the next one. So argon is over here, which is in the 3p section. So all we're going to do, and it's really quite easy. Sorry, can you see argon? Sorry, it's right there. All we're going to do is we're just going to go in order. Okay, 1s is first, 2s's, 2p's, 3s, 3p's. And we're just going in order. We're writing how many we have. So for argon, we need to go through the 1s's. How many electrons are there, or how many elements are in the s's? 2. How many are in the 2s? 2s. We have another 2 electrons, or 2 elements. Then, once again, 1s, 2s. Now we're hitting the 2p's. So we put 2p's. And because we have full electrons in the 2p's, we are going to put a 6. That's as much as we can have. we have 2s, or sorry, 3s next. 2 electrons there. And then for argon, we're in the 3p section, but argon is the last one. So we have 1, 2, 3, 4, 5, 6. So that's why we put a 6 there. So that's the electron configuration for argon. Okay? So hopefully that makes sense. All right. Let's try one more before we move on. Okay, let's see if you guys can go and get copper. Let's see if you can come up with the configuration for copper. Actually, sorry. Maybe you guys stopped it. Actually, sorry. Copper is not the best example because it is actually a special case that you'll look in grade 12 or post-secondary. Sorry, let's go with cobalt. Yeah, cobalt will work. Okay. Okay, so let's try cobalt here. Okay, now once again, you need to figure where cobalt is. Okay, it's in your it is in your D section. Sorry, I'm just trying to think of something here. So let's go in order. Okay, so first we need to go through the 1s's. Then we have our 2s's. We have our 2p's. Okay, it's full. Okay, we have 3s's that are full, 3p's that are full. Okay, now we're in the 4s. Okay, so we passed those. And now cobalt is in our D section. It's in the 3D section. Okay, so 3D for cobalt. And how many across are we? So here's my cobalt. 1, 2, 3, 4, 5, 6, 7. And that's what we have here. Okay, so hopefully that's not too difficult to come up with. Now, one thing I want to show you guys that maybe you've seen or maybe you haven't seen. Actually, before we get there, let's try the next example that I have. Sorry, we'll get to there after I have a couple more examples. Sorry. Okay, let's try our ions first before we get to the short form configurations. I was kind of jumping the gun there. Okay, so let's go ahead. I'll give you guys a second. See if you could try both of these. We're going to do the chlorine ion and the sodium ion. Okay, now after you do both of these, tell me which noble gas, which one are these isoelectronic to? Okay, chlorine and sodium. So take a second, come up with the electron configurations and tell me which ones they are isoelectronic to. All right, so chlorine here, it's over here. We're in the 3p section. Chlorine ion, we're gonna add 1 electron. Okay, so if you put your isoelectronic, it should be isoelectronic to argon. So let's go ahead and let's do this here. Okay, so for chlorine, we're gonna have 1s2, 2s2. We're gonna hit the 2p's. Okay, we have the 3s. Okay, and chlorine, and once again, chlorine ion is 1 negative. 1 negative means that we need to add an electron. So normally, chlorine is 3p5. I'm not going to write that in. Okay, and once again, if you're not sure about that, p's are here. We have 1, 2, 3, 4, 5. But because we're adding an electron, it's going to look like argon. So it's going to be 3p6. Now, which noble gas would this be like or isoelectronic to? It's going to be the same as argon. Once again, we added an electron. We went from chlorine to argon. Okay, so we're adding 1 electron to look like that. All right, so for our sodium, same idea. Okay, sodium's here. It's going to be 1 plus. 1 plus, okay, means that we lose an electron, so it's going to look like neon. So if we're going to do our electron configuration, sodium is 1 plus. So we're going to have 1s2, 2s2, 3s2, and we would have 3p6. Now, sodium would actually be, sorry, did I jump one here? 2s2, I'm sorry, I made a mistake. I was looking at the wrong one. Sorry, 1s2, we have 2s2. Okay, we hit the 2p6, which is neon. And then sodium is actually 3s1, because that's where this is, the 3s, the first one there. But because we lost an electron, we don't need it, so we have that, which is just 2p6. And this here is isoelectronic to neon. Now, what if I asked you to come up with like mercury here, Hg, number 80. Do I expect you to do 1s, 2s, 2p, 3s, 3p, all of those? You're going to have a whole paper full of these numbers. No. So what we can do, and that's why it's extremely important that you guys know how to do your isoelectronic and figure that out, is that we can change it up. So for example, if you look at chlorine, chlorine is this. Chlorine is, okay, chlorine's over here. It'd be 1s2, 2s2, 2p, 3s, 3p, and all the way, or sorry, 3p here. So instead of having to write all of this, we can go to the shortest or the closest noble gas and continue from there. So what I mean by that, okay, I'll show you guys here. Okay, there's an example there, but so for chlorine, chlorine would look like this. You would have 1s2, 2s2, 2p6, and then you would have 3s2, and you would have 3p5, because chlorine is the fifth one there. That's what chlorine is. If you're not too sure, go ahead and try it. 1s2, 2s, 2p, 3s, 3s, 3p, 5, because it's the fifth one. Now, what you'll notice is that this here is the same configuration as neon. So what we can do, and if you take a look here, is that we don't have to write all this out. We can actually just put neon, and then we add the remainder, 3s2, 3p5. Okay, so let's try another one before we get to tin. Okay, so let's try, for example, let's try like bromine. Okay, I'll do bromine over here, Br. Okay, just to show you guys how we would do this. So this is bromine normally. Bromine normally is 1s2, 2s2, 2p6, 3s2, 3p6. We would have 4s2. Oh, I'm running out of room here. 4s2. We have 3d10. And then we would get to 4p, 1, 2, 3, 4, 5. Okay, I'm sorry that I ran out of room here, but that's what you'd have. 1s2, 2s2. And once again, if you're not sure, bromine's over here, right? So we have 1s2s, 2s, 2p's, 3s, 3p's, 4s. This one here, once again, we jump down an energy level. And once again, if you're not sure, use this sheet. It's right here, 3Ds, right? 4s to 3D. And then we have our 4Ps. Now, what is the last noble gas that we passed? I didn't mean for that to rhyme, but the last noble gas that we went through was argon. So what we can do is that we can start from argon. So what I'm going to do is I'm going to put bracket AR, because that's the last noble gas that we passed to get to bromine. And then what was remainder? Okay, so this here is 4s2. Right, if you take a look, 4s2. So that's where I'm going to start from. I'm going to start from right here. 4s2. I passed my 3Ds completely, so that's my 3D10. And lastly, I'm going through my 4 P's, and I went 5 of them. So essentially, both of these are the exact same, but we didn't have to write all the beginning part. So this 1s, 2, 2s, all the way to the 3p6, this could be replaced with that argon right there. So this is what we call the short form configuration. Okay, so let's go ahead and see if you could try this one right here. Write the shorthand configuration for tin. Okay, so I'll give you guys a second, or just pause the video and then we can try it out. All right, so tin is SN. Okay, so once again, first thing, find it on your periodic table. Here's tin. What's the last noble gas that we went through? Okay, so helium, neon, argon, krypton, and we haven't got to xenon yet. So the last one that we passed was krypton. So my first starting spot is I'm going to put a bracket, krypton. That's where I'm passing. Next, to get to tin, where have we gone next? We went through, this here is 1s, 2s, 3s, 4s. This is the 5s's. So to get to tin, we're at 5s, and we pass through 2 of them because that's how many are in the S's. Okay, next for krypton, or sorry, for tin, here's your 5s. These are the 4 D's. Remember, it's one less. Okay, so once again, if you're not sure, here's 5s. The next ones are 4 D's, and there's 10 of them, and we passed them all. 4D10. Okay, and then once we hit the 4D10, we're over here, which is the 5 P's. And once again, if you're not sure, you can look at that sheet. And for 5 P's, how many did we go in? We only went 1 and 2. So that's what tin here would be. It would be krypton. We passed 5s, 4 D's, and we only went 2 into the 5 P's. Okay, now the last thing I want to show you guys before we end this lesson is that if you're ever unsure, okay, if you look at your periodic table, if you look at tin right here, underneath, right above the name, okay, it might be hard with the one that I printed off for you guys at the beginning of the year, but if you go on our website, I have a nice PDF version of it. Look, take a look at tin right here. It's bracket KR, 4D10, 5S2, 5P2, that's the exact configuration that you have here. The only thing that you'll notice is that on the periodic table, they like to put the numbers from lowest to biggest. So here they have 4D before the 5S, even though we go through 5S's first before we get to the 4Ds. Once again, that's not a big deal. Once again, the only reason why they're doing that is that they like to put the numbers in order. They like to go from the smaller numbers to the bigger numbers. Either way, I would mark them both correct. Okay, so hopefully that makes sense to you. What you want to make sure that you can do from this lesson, okay, you want to make sure, okay, that you're able to, and I'll just kind of go through it real quick, just so that we're all on the same page. Okay, you want to make sure that you know the different letters, how many you have, what they look like. Okay, when we draw our arrows, they look like that, opposite spins. Okay, we looked at a couple definitions, and I'll just pull out my definition sheet here. Once again, make sure you have it. Aufbau's principles, Hund's rules, Pauli exclusion, sorry. And then we looked at just some examples on how to, Okay, and then we looked at, where are my sheets here? Sorry, they're just in the wrong order. Here we go. This is the second one. Okay, so we learned how to do this, these energy level diagrams. Okay, these are the normal ones. You should also be able to do it for some ions. So if you're adding or taking away electrons. Okay, you should know what the word isoelectronic is. And then lastly, we looked at our electron configuration. So we have these ones. We looked at some ions. Okay, and then lastly, shorthanded ways of writing them. Okay, so I'm going to ask you all of them, so please make sure you know how to do that there. Okay, so thank you very much for listening and attending our video lesson. Have a great day.